Mm. Hi guys. So here we have a demo for the Bitcoin SPV Relayer, which relays block headers from Bitcoin node to the light client, and also the transactions SPV proof whenever there is a new transaction. So here we have three processes. One is the Bitcoin node ran by the Bitcoin D reg test process. Second, we have the Bitcoin light client, and third, we have the relayer. So here, here is the Bitcoin D node running. We can check if the node is running by doing something like this, or maybe. So here you can see it's at block number 231, and so this is the first process. Second process is our light client. As you can see, 1 minute. So to run the light client, you just run the main with data JSON. So the purpose of this JSON is, if I show you, yeah. So this essentially has an initial configuration for the light client. One is what kind of network it should have configured. So since our Bitcoin node is in reg test mode, here it also has to be the same type of network. Then, since we are starting from height 1, for the light line, we said the starting height is height 1. And then we have block headers, we have 20 block headers. These are from the reg test node from block number 1 to 20. So now we have started. As you can see, the RPC server for the light client is on this port. So now we need to connect both of these through the relayer. Here first we can build now. To run this, we run the relayer process with the YAML configuration file. If I show you what this looks like, this has like, so three parts it has which are of our use to this current process of relayer. One is common, which essentially is how logging should be, and whenever things are retried, how much wait time should be there. Then this is configuration, telling what kind of Bitcoin node we are connecting to. For example, here we are telling it's a Bitcoin D node, not a BTCD. Both are supported here. So if it's a Bitcoin D node, then the block events are emitted by the Bitcoin node through a thing called a ZMQ. So we need to also specify this, which is what kind of endpoint uh, the relay should connect to listen to the ZMQ events. And other than this, we have your RPC endpoint, and we also do have username and password, and also need to tell that it's a reg test type. And yeah, that's all we need for now. So if I run this, you will see it's able to see that okay, the Bitcoin node is at block number 231. It's able to see what's the latest tip in the light client. So light client, once you query what's the latest block, it will give you what's the latest checkpointed block, which it assumes is the is the finalized block per se. So for example, in this case, we had 20 blocks as the starting 20 block headers. So if it has 20 blocks, why it took 13 as the finalized one is because you have 7 more blocks on top of it. So a safe number to assume that the block is finalized is somewhere around 678. So here it's returning that okay, 13 is the finalized one. So after 13 it'll keep on sending new blocks, and then it will finally send the remaining ones here in batches of 100 blocks at a time, and then it'll initialize a sort of a cache for headers. So whenever we have new events of new blocks coming in, those will be first going into the cache, and then into uh, the light line itself. So now we have all three processes started. We can now produce more blocks to see if this new block is caught by the relayer and then sent to the light client. So to produce a new block, we can do this. Okay, so this is produce new block with this block hash. You can go and check if this has been the case by doing, let's say, this. Now you will see it's 232. We go back to relayer. We see that okay, it has found a new block, then it has submitted that to the relayer, to the light client, and then since there is always one transaction whenever you generate through rec test in a new block, uh, it'll always have one transaction every time there's one block. So it has also read that there has been one new transaction in the new block, so it generates the SPV proof of that. Four components in the proof itself. One is your transaction ID, one is your list of Merkle path, which is this. Transaction index is at what index this transaction is in the block hash, and then I guess the block. So this is the block hash. This is the uh, this is the transaction ID, and then transaction index, and then the Merkle path, right? So you can see we submitted the proof to the relay, to the light client, and then we got a response from the light client. So the response ID 1. So if you go to the light client, we'll see that first it was able to listen to all the new headers that were incoming, and when the transaction happened on the Bitcoin node, relayer sent the proof to the light client. Here you can see the proof was received as was sent by the relayer, and then upon parsing it, it found that okay, this proof is valid, but the block is not finalized, which is uh, how it should correctly be, because since block 232 is the latest block in the light client, there are no at least more than 7 blocks above it, so the block itself is not finalized. So whichever transaction is part of this block will not be finalized, which is true in this case, right? So this is the flow of valid transaction, proof being sent and being verified correctly. Now we can do an example where we can, let's say, modify the Merkle path to create an invalid proof. So if there is an invalid proof sent by the relay to the light client, it should be able to detect that and say that okay, this proof is invalid, right? So let's see, let's first stop the light client, let's stop the relayer, and now what we can do is yep, so here the proof is being generated. What we can do is let's comment this out so that now the Merkle path itself is not correct. Commented out to create an invalid Merkle path, right? So let's build this again. And now we run it. Okay, 1 minute. First we need to start the light client again. Yeah, so light client again. Finalized block is 13. Latest is 20. Okay, so it has synced. Now we check again. Here at block 32, we can generate one more block. And we go to Relayer. We see that it was able to receive the 233 block. Then it was able to see that there's a new transaction, created the proof, submitted the proof, right? And here you can see this Merkle path is not the correct one. So if when we send this, the response should be that okay, this proof is not a valid one. Which in case you see last time we had response code 1, which was for the proof is valid but block is not finalized. Response code 2 is block is finalized and the proof is valid. Response 0 is the proof is invalid. So if we go back to the light client, you can see proof was received and proof was marked as invalid. So yeah, thanks a lot, and yeah, let me know if you have any questions.